Welcome to a free Python course. I know this might seem like something that's not valuable because it literally has been done millions of times by people with millions of followers. But there's one thing wrong with these courses. They're typically created by somebody who has years of experience, and they usually don't account for the fact that people watching typically have little to sometimes no experience with software and don't understand how it works. But this course is different because before I even release this, I'm going to go through countless surveys with people who have zero knowledge about coding or computers and perfectly etching the course to be the most digestible beginner tutorial ever made. And with that said, enjoy the show. Before we hop into code, let's first understand how computers work. All computers have something called RAM, which stands for Random Access Memory. This is where programs that are actively running will by default store things like numbers, text, addresses, instructions, etc. The confusing thing is that when you look at this image, what do you see? This is the number 65 being stored in your RAM, but it doesn't really look like that. Why? Because a computer can only store a 1 or a 0, also known as a bit. Every day we use a base 10 number system, which includes 10 unique digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, which when you reach the base number of digits, you add 1 to the digit in front and start back from 0. You can have any base number system as you want. For example, a base 9 number system starts at 0 and goes to 8, and once you hit the base number, you loop back to the front. There's 3 systems that we really use as a programmer: base 2, base 10, and base 16. With base 16, we don't have any traditional numbers that go past 9, so we add an A to the front until it goes to F. This is called hexadecimal. It's quite often to see something like a color be represented as base 16, but let's go back to binary. In binary, we count starting at 0, then we go up to 1, which in decimal is still 1. Then when we want to count to 2 in binary, we reset the first digit to 0 and add 1 to the left of it. This is how we use bits to count. 8 of these bits equals a byte, which is what we use in RAM. We read each block of information as a byte. Knowing this, let's look at our RAM example before. If we convert these 1s and 0s to a base 10 system, we read it as 65, but it can also be read as the letter A. How is this possible? I thought we just said that it was a 65. Well, it is if you're reading it as an integer. But what if we read it as text, also known as string? It's still a 65 at the end of the day, but when we read things as a string, we use something called the ASCII system. It's a random set of characters that somebody named Bob Bemer in 1961 came up with, which is a way to pair a number with a character. A ridiculously large majority of modern computers use the ASCII system. So when we read this set of binary digits as an ASCII character, it's actually going to be read as the ASCII counterpart of 65, which is an A. The meaning of the byte all depends on how we read it. This understanding is going to be crucial later on in this tutorial when we tell our code how to read the data that we saved. I know number systems can be a bit confusing, so if you guys want to understand it a little bit better, I left a recap at the end of the video that will hopefully help you piece it together. Now that we know how a computer stores values like text and numbers, let's go and take a look at other things that can be stored in RAM, like an instruction. What is an instruction? An instruction is a byte or series of bytes that correspond with a command to your CPU. Understanding these instructions are super difficult and come way later on in your computer science journey. But just know that when you're writing a Python code, your CPU has no idea what you're saying. You need to pass the code through something called a compiler, which converts these blobs of text into a corresponding set of instructions that will perform the task that you asked it to. The CPU can understand these instructions after being compiled. Now, when we're testing our Python code, we don't need an exe every time, which is what you get when you compile. We'll use something called an interpreter that will convert it from text to run it right away. The only issue is that you can't easily distribute it without it being compiled to an exe. So now that we understand all this back-end stuff, let's get to coding. Code is just text, so in order to write code, you need a space to write code on. You can write code on anything, but it's better to write code in something called an IDE, which stands for Integrated Development Environment. Imagine it as Notepad, but for programmers. Here's how you install my favorite IDE called Visual Studio Code. You're going to go to code.visualstudio.com/download and click download for whatever operating system you're on. Once you're inside of Visual Studio Code, you're going to navigate to the Extensions tab and search for Python. Once you've downloaded the Python extension, click New File and make it a Python file. Now that we have our Python environment, which once again is a fancy word for place to write code, let's start with the most popular way to begin your coding career, with a hello world code. So I know you won't understand this right away, but let's just type it out and then go back and look at it. So what are we looking at? Let's break this down into 2 parts. First, we have something that we haven't covered yet, which is called a function. A function is something that does something. This isn't very descriptive, so let's look at a visual. In this case, we have an add function. This this function will take in two numbers, let's say a 5 and an 8. These are called arguments, and they go between the parentheses. This function will return to us the sum of these two values, which in this case is 13, and this is called our return value. Let's look at another example. This is a connect Wi-Fi function. It takes in a Wi-Fi name and connects to the Wi-Fi. It might not have given us a return value, but not all functions give us one. Now a check connections function. It takes in as many Wi-Fi names as we want, separated by commas, then goes and checks all the Wi-Fi names to see if that Wi-Fi is connected, and will return a true or false for each individual one. Let's look at one last function. This is a disconnect all Wi-Fi's function. It takes in no arguments, goes and disconnects all connected Wi-Fi's, then gives us no return values. Let's take a step back and look at the function again. What is print? Print is a function that takes in as many values as we want and will display all of them to the user's screen separated by a white space. In this case, we're only passing through one argument, which is hello world, but you're not limited to hello world. Which brings me to the next section. Hello world. Why is it in quotations? The reason it's in quotations is because we want to tell our computer how to store this data, and later on how to read the data, which in this case is a string. But you also can have something like a number stored as a string, which instead of being stored in your RAM traditionally, the number will be converted to its ASCII equivalent of 53 in binary, which is different to if you stored it as an int, which is a number. In that case, the computer will store it as the direct number in binary. But the difference is that you can do mathematics with an integer, but you can't do mathematics with a string. Knowing this, if we go back to the print function and we want to pass through the number 1, we have two options. We can pass it through as a string, or we can pass it through as an int, which you can simply type out. But you can't use text as an integer because something like hello world isn't a number. Finally, let's take our last step back and take a look at the entire program. We are telling the print function to display on our screen the string hello world, and that's all. I hope you're proud of yourself. The goal of this video wasn't to simply show you how to write your first Python code, but it was to give you the foundational knowledge of how computers work and how they use your code to do what you ask them to do. All right, I'm here in the flesh, everybody. I know it's a little bit dark. I'm here in the flesh, and I'm going to be doing a little bit of a recap from that last section, just on a piece of virtual paper, in case some of you guys didn't pick up what I was putting down. So first, what is RAM? RAM is how your computer stores memory. Now, how does it store memory? Can it just store an image sitting in your RAM? Well, yes, but it doesn't look like an image. What does it look like? It looks like a bunch of 0 and 1s. All computers are limited to binary. What does this mean? That means that they can only store a 1 or a 0 in their physical RAM. So if that's the case, how do we store something like a 10? Well, we count in binary. And binary is a base 2 system, which means that you can only have two combinations, 0 or 1. Meanwhile, in a base 10 system, you have all the numbers 0 through 9, which adds up to 10. So in our base 2 system, let's go and take a look how we can start counting. So we're going to start counting with 0, like always. All base systems will start counting in 0. Then, when we want to move up to 1, literally all we do is we add a 1. The only time that we end up moving to the left is when we hit our base number. And our base number in this case is 2. So can we actually write a 2 here if we only have 0 and 1? No, we can't. So what we're going to do is we're going to move the 1 to the left, and we're going to add a 0 in its place. So now this is 2 in binary. Now let's say we want to increment it by 1 and go from 2 to 3. Well, we look here, and we can just add a 1 on the end, because 1 more than 0 is a 1. So now this is 3 in binary. So if we want to count from 3 to 4, the thing is, once again, we don't have any numbers that go past these two 1s. So we're going to reset them both to 0, and we're going to add a 1 at the end. Now, if we want to go from 4 to 5, we can just increment it by 1. And if we want to go from 5 to 6, we can't increment this again. So like we said before, we're going to add a 1 here and reset this to 0. 6 to 7, we're going to do a 1 here. And then 7 to 8, we're going to reset all 3 of these, and we are going to add zeros like this. So this is an 8 in binary. I just know that this is 65 off the top of my head. But this can also be read as an A. Why? Because of the ASCII system. The ASCII system pairs numbers to letters. So 65 is an A, 66 is a B, 67 is a C. So if I want to go and I want to read this as B instead of A, what we're going to do is we're going to reset this to a 0 and add a 1 up here. So now this is B in binary. And if I want to go to C, bam, now we're at C in binary. Let's give one more example. Something like this. If we convert this to decimal, we get 49. But if you convert it to hexadecimal, it's 31. Now, what is hexadecimal? Hexadecimal is a way of counting that is base 16.
instead of base 10 like we use every day, or base 2, that's also known as binary. This array of bits has an infinite number of meanings, and what it means depends on how we read it. So this could be a 49 in decimal, but it can also be a 1 in text, and it can also be a 31 in hexadecimal. So this is why later on in our code, we're going to have to tell our code how to store this data.